All right, 8.3 logarithmic functions and integration. So this is all about integration, this unit, or this section rather. The previous section was about finding the derivative of logarithms, and this one we're doing the antiderivative. So, as you see, here are your rules, okay? If it's 1 over x or 1 over a function, it will just be the integration of that is ln of x, ln of u respectively. As we get into various functions, there are certain little things we do to help solve those, but this is essentially the rule. So here are two examples. One is going to be very straightforward. One we have to do a little extra work with. We have the integral of 1 over x plus 1 dx. This right here, we look at this below. What's the derivative of the denominator? It's 1. So everything's going to work out. So we can simply just take that function and write ln of the absolute value of x plus 1 plus c and call it a day. We're good. This one, on the other hand, I know this is not, we don't need to do full-blown u substitution, but we are going to do a little bit just for this sake. We get 2x plus 1 du is equal to 2x dx. So if I work to get dx alone, right, it would be dividing by 2x as we would. And what do we notice? We don't have, it's not going to fully cancel out, right? This has an x right here. So because we have a 2x as opposed to just simply x, we need to multiply by 1/2. Why 1/2? Because that's what's left over. If we do x over 2x, we're left with 1/2, right? So we're actually integrating 1/2 the integral of 1 over u du. And then you integrate 1/2 ln of u, absolute value of u, as our rule says, plus c. And then we substitute in our u. 1/2 ln of the absolute value of x squared plus 1 plus c. There's a little more to this one, but let's go through the u again. U is equal to x cubed plus 3x squared plus 9x. Derivative dx. Okay. So how does this compare to numerator up here? What would we need to do in order to get these two things? Well, if the numerator is multiplied by 1/3, or this was multiplied by take that back. If the numerator right here is multiplied by 3, or this multiplied by 1/3, we would get each other, okay? So when we divide, like we normally would, by 3x squared plus 6x plus 9, the difference between these values and these are simply just 1/3. So I'm going to get 1/3 right here. 1/3 of 1 over u. Okay? And integrate it. I'm going to do 1/3 of ln of absolute value of x cubed plus 3x squared plus, oh, did I write 9x right? Yes, I did. Okay, 9x plus 9x plus c. We have the integral of x squared minus 3x plus 2 divided by x plus 1. When we have a problem like this, we have to go back to our long division days. I'm sorry if you don't like long division. But you're not going to get anything too crazy by doing long division, but I will give you one or two that could be somewhat similar to that. So what times x gets you x squared? It's x. So it's going to be x squared plus x. Subtract, you can get negative 4x plus 2. And then up top, what times x gets you negative 4x will be negative 4. Negative 4x minus 4. Subtract, and you'll get 6. So what does that mean for us? So that means you're actually integrating x minus 4 plus 6 over x plus 1 dx. I forgot to put dx with the original problem. I should have done that. Now, if we did all these individually, you'd have an easier time, right? Minus 4 plus integral of 6 over x plus 1. So over here, we got 1/2 x squared, right? Because you add 1 to the exponent divided by the new one. This one right here, we have 4x, right? Because any integral of a constant, as hopefully you remember, is just going to be that constant times x. Over here is where we have our u's, and then what's going to happen differently here? Well, use substitution, it'd be your basic rule, but 6 would be left over. So if we move 6 up front, which we could, move it up front, we would get plus 6 ln of the absolute value of x plus 1, all plus c. All right, two separate problems where we have to use u sub in its own different ways. I'm going to do the one on the right first, though, okay? I'm sorry if you're writing them out of order, but I think this one's much easier on the right. I'm going to set u equal to ln of x. What do we know about du? It's going to be 1 over x, right? Dx. And then we multiply both sides by x. We get x du equals dx. And I'll substitute in what I just said. So we get the integral of, I'm going to substitute in my u, so we get u squared over x. I'm going to put in x du in place of x. The x's cancel, so I'm integrating u squared. That's going to be 1/3 u to the third plus c. And then we plug in our u, and that's going to be ln of x. So 1/3 ln of x cubed plus c. And so we do the one on the right. Now the one on the left is a little different u sub than what we're used to. Okay, I'm going to set u equal to the square root of 2x. Now, when we do that, when we try to find our du, before we do that, let's make our lives a little easier, because find just the derivative of a square root is going to be a little hard. So let's square both sides. We get u squared equals 2x. It's a little easier to work with, right? Now we can integrate and find it'll be 2 dx on the right. And on the left, you get 2u du. We're going to need to isolate our dx, so we're going to get u du equals dx. So we get 1 over 1 plus u. And what do we include there? We also need to include, what's dx equal to? U du, right? And go in different colors just so you can stand out. That's going to get me the integral of u over 1 plus u du. And once again, we can do our quick long division here. So if I do 1 plus u, I put it in order, I know that, but if I put 1 up top, u subtract, you're left with 1. So I can change this to 1 plus 1 over u du. I integrate that, I'm going to get u plus ln of the absolute value of u plus c. And I substitute in what u is. That's going to get me square root of 2x plus ln of the square root of 2x, absolute value of that, even though that has to be positive, and then plus c. So quick little thing, so if we're integrating a to the power of x dx, the a value goes in the bottom with the ln of a, times a to the x plus c. Okay, that's the process for these types of problems. So if I have integral of 3 to the power of x dx, that would be simply 1 over, what's our a value? 3, so ln of 3, times itself, 3 to the power of x plus c. Yay, we did 1. All right, appreciate you watching, and we'll see you later. Bye-bye now.